Hi everyone, so this is the main interface for my workout analyzer. So first you can input your weight. I'm 70 kg, so I input 70. Next, this is the targeted workout time. So targeted workout time is the time you wish to work out for. It can come in hours, minutes, and seconds. And for illustration purposes, it'll be 1 minute. Now, time is the elapsed time from the time you start running the program to the time you decide to stop the program. Next, there are three workout choices for my program, mainly walk, jog, and run. So you can toggle them, 3, 8, 14. That is how you choose the different workout choices. Next, this indicates the number of steps you make in during the workout. As is this a shared value or to run the other program first and before running this program. I'll show you more later. Next, this is the progress bar, and this is the calories burned. Calories burned here is relied on the metabolic equivalent of task value, which reflects different values of MET value for different types of activities. And you can see jog is 3, jog is 8, walk is 3, and run is 14. And this is obtained from National Cancer Institute in US, their website. Yeah, finally we have the progress bar. Progress bar is actually the ratio between time and workout time. So this is the main interface for my workout analyzer. Now let's take a look at the block diagram behind the first interface that we have seen. So now you can see that the elapsed time will give you the time value, that's a numerical value, and from there you can input the targeted workout time, that's a user input. Remember it's a ratio and it gives you the progress bar. So you can obtain the value by dividing elapsed time over the targeted workout time. So now weight is a user input value. So you multiply with the workout choice, which varies between 3, 8, and 14 MET's value. So you can see there. And they are multiplied together with the total elapsed time to get the number of calories burned. So now the time is in 3600 is because the formula is weight times workout choice, the MET values, times time in hours. That gives you calories burned. So this is a shared value of the number of steps, and the shared value is shared to the first user interface we saw at the front. So this is a basic storing VI. So by running the program, you'll be able to save the acceleration value shared by the previous interface, the second interface. So as there are three values to the acceleration, namely the x, y, and z values, you have to do that 3 times. You also notice that the file is saved in an Excel sheet, which will be easy to open as it's a very common software. This is the block diagram of the sharing VI. So there's 3 shared variables from the second interface. So it goes into the write to measurement file and it's controlled by a button. So this is the main analysis page. And the first graph we have is the stride analysis. But before all this, we must be sure that we attach the MyReal device to our shin or the thighs, and the device should be facing forward. Now, first, the stride analysis. So when I'm standing straight and tall, the curve that I should see is a smooth sine wave. Now, when I take a stride, or when my shin is moving, the graph becomes a sharp triangular graph. So the proper execution of a run should see a variation between the curve and sharp graph. That will indicate a correct running posture and style. Next, there's leg movement analysis. Now, if my leg is moving in a straight line, you will see a continuous smooth sine wave. However, if my leg is moving in an awkward position, we will see a sharp line. And this is not what we want. We should always strive to get a smooth sine curve. Now you may notice that both graphs are similar. Now the only difference is that the strike analysis uses the z value of the accelerometer and the rate movement analysis uses the x value of the accelerometer. The third graph we see is a basic accelerometer readings, and I have split the graphs into 3 graphs for easy analysis. Now we move on to the strike length analysis. The strike length analysis is controlled by the threshold value, which will adjust the red dotted line, and is also controlled by the width, and together they affect the number of steps detected. When a step is detected, the LED light lights up. So now make sure you set the width to 1 to not discount itself, and if the threshold value is low, you'll detect more steps. And this is the analysis page for my workout analyzer. So this is the block diagram of the analysis page. First we have it's not in order. So the first one is the accelerometer table where there are 3 graphs. So basically you initialize and you acquire and process the values. And the values are displayed in this acceleration graph over there. Next, we have this. There's the strike length analysis. So as mentioned, strike length analysis gets its value from the z-axis, and together you will find this amplitude level, and this block will help process the amplitude lines and make sure that it kind of covers the graph. And here is for the zoom button. So basically it's not a zoom, but it's to make sure it fits into the graph. Yep. Here we detect the peaks in the signal. So using the accelerometer value, also the z-axis, we multiply by 10. The reason is because if we don't do it, the signal value will be too small to be seen on the graph. So we multiply by 10, it comes into this Q, and this is the threshold detection. And from there, we can find out the threshold, we can determine the threshold, the width. And this will help determine the number of steps over here. So using the for loop, we use the indices to plot the graph, and we output it into the waveform chart. Finally, we have this. So this is the second interface that the user will see. So basically the 4 circles there represents the 4 LED lights you have on the MyReal system. And this is a motion detector. So it detects how much motion you have onto the MyReal itself, which means the amount of impact you have onto the ground. So the goal is to make sure that the last LED light does not lit up, because that will mean that the impact onto the ground is great. This is the block diagram of the motion sensor. So on the left, we have 2 initiations. Top one will initiate the accelerometer. XYZ values will be square, add, and square root. This will go into the array, and the values will affect, the magnitude of the values will affect which LED lights will light up. After the accelerometer, the acceleration values are also shared, and these values will go to the saving VI, where it's a simple storage VI. So that's all for my project. Thank you so much.